Hi, I'm going to talk to you about data collection. By this time, you've decided on your research design, you've constructed a research instrument, decided on the sample. Now it's time to go and collect some data. Let's get started then. We're going to review or discuss the various data collection methods available and the error in gathering data, broken down into sampling errors and non-sampling errors. Finally, we'll look at response rate and response rate related issues. There are many ways of gathering data. You could call somebody, meet them in person, send out mail surveys, web-based surveys, or app-based surveys. The choice of what method to use depends on a number of factors. These have got to do with the nature of the study at hand, such as task factors, situational factors, and respondent factors. Specifically, if you have a lot of different kinds of questions to ask, and you want some sort of flexibility about your survey to ask unplanned questions, maybe in person or phone is the right way to go. If you want to show some physical stimulus, well then it has to be in person. There are times when you want sample control, and the instrument or the method used might affect your ability for sample control. For instance, if you decide to do a web-based survey, you may be limited to those who have access to the web. Now, in today's world, that may not be a consideration. But let's say it's an app-based survey, or it's a social media survey. People on that social media platform or app are then those people you can collect data from. If a large amount of data is desired, certain methods are better than others. For instance, if you are interested in gathering a large quantity of data, a phone-based method may not be appropriate. On the other hand, with web-based surveys, you can gather a lot of information. With certain methods, response rates tend to be higher. In-person data collection methods typically yield higher response rates than do phone-based methods, than do mail or web-based methods. There are also considerations about situational factors. If you're doing a web-based survey, then you have less control over where the respondent completes the survey. They may be distracted, they may be multitasking. They may be doing it on the go with unstable Wi-Fi, resulting in a drop-off of their from the survey altogether, which means they might rejoin and in a different state of mind. So there's much less control in a web-based environment than in person or on the phone. There are also considerations about the field force, for example, and interviewer bias. Whenever you're using phone surveys or in-person methods, there might be bias from the perspective of the interviewer. Does the respondent feel like he or she's being judged by the interviewer? Does the respondent feel like his responses are going to be held anonymous? These are some considerations as you think about having a human posing the questions via a in-person or phone-based survey. There are also considerations about speed and cost. Certain methods cost more, certain are faster. Specifically, you can think about web-based surveys cost a fraction of the amount of money that a in-person survey method might use. So in most situations, cost is a huge factor. And given the fact that in-person or multi-intercept surveys can cost a lot of money, web-based is the most widely used option by companies. There are also considerations about respondent factors. If it is a web-based survey or a survey done over an app, then the respondent might feel like that their responses will be held anonymously. Versus in person, they may not feel like it's a secret, like the responses will be held confidentially. There are also concerns about social desirability, is about looking good. And this might be more relevant when the respondent feels like he or she must impress the interviewer. Similarly, web-based surveys might be better for gathering data on sensitive information, right? And so on. So bottom line, each of these methods we have out here have certain benefits and drawbacks. There's better in certain circumstances, worse in others. Web-based surveys are by far the most popular method today for gathering data, simply because the costs are just a fraction of what it is in case of other methods. And that seems to be a key consideration in the choice of data collection method. Now, when data is gathered, it's good, data has been gathered, but one can't be sure that it is reliable, it's error-free. So let's examine the kinds of errors that might afflict our data gathered from the data collection method chosen. Broadly speaking, you can break up error into random sampling error and non-sampling error. Now, random sampling error is the good kind of error. I know it seems odd to call any kind of error good, but in fact, the good thing about random sampling error, and the reason I'm calling it good, is because it is random. It doesn't introduce bias into the system. Random sampling error occurs because we are asking a subset of the population to respond to our survey instrument. This means there's bound to be some level of sampling fluctuation. If you ask another group of 100 people, then you might get slightly different responses than the 100 people you asked now. Given that this variation is totally random, that there's no room for bias, we can estimate the level or amount of error. And that's why sampling error is the good kind of error, because while it does represent a random error component, it can be easily estimated. So we have confidence bands we come up with for the error. On the other hand, non-sampling error cannot be, it's hard to address or measure non-sampling error in the same way as random sampling error might be measured. Another thing about random sampling error is that random sampling error reduces as sample size goes up. With non-sampling error, you might have the exact opposite effect. That is, a larger sample, rather than reducing the error, might actually increase the level of error. Now, non-sampling errors can be broken down into a number of categories. There's non-coverage error, there's response error, and non-response error. Let me go through each one of these in more detail. The first one is non-coverage error. Non-coverage error occurs when you don't ask questions of some people. This might be because of how the sampling frame is defined. The population is who we want to gather data from, but not everybody in the population may be accessible based on the method we choose. And therefore, one might decide to use a sampling frame to draw a sample from. Even though the sample is random, some people from the population would not be included because they are not part of the sampling frame. For instance, if you decide to do a web-based survey, which requires knowing the respondent's email address, only those with valid email addresses would be part of the sampling frame. Thus, we are limited to those who have valid email addresses. Similarly, if you decide to use, in certain instances where data is gathered in certain environments, like a mall intercept survey. A mall intercept survey involves gathering data from those who happen to be in the mall. If the target population involves mall visitors and non-mall visitors, then the sampling frame of using the mall to gather data from has limited us to just folks who are in the mall. Those who are not mall goers would be automatically excluded, and that would create a non-coverage error in our analysis. Then there's response error. Response error occurs because of errors in the responses gathered. This might be because of what people have said is not exactly true. All sorts of things might affect or cause response error. They might be errors caused because on the researcher's part, the researcher didn't measure the information correctly, didn't code it correctly, defined the population incorrectly, defined the sampling frame incorrectly, or it could be a transcription error. It could be a data analysis error. These are all errors attributable to the researcher. In addition, you could have interviewer errors, errors arising from the fact that the interviewer picked a respondent who shouldn't have been chosen, for instance. The question was asked incorrectly. Sometimes interviewers will abbreviate a question when they shouldn't be doing. They didn't code the answer correctly, or sometimes they just flat out lied. Interviewers are paid for getting responses from respondents, and they might just fake a survey or two. That could be a source of interviewer error. Lastly, there are instances when the respondent may answer the question, but not do so truthfully. Now you'd wonder, why would a respondent lie in a survey? Well, for a number of reasons. One of them being because they simply don't know the answer to a question, and they feel like not knowing would reflect poorly upon them, so they say something anyway. Or they feel like they don't want to answer a certain question. Right? And so these might be, again, reasons why you might see, for example, they may not want to share their true income or their true opinion on the attitude towards, let's say, firearms. And so they might lie about it. So these are response errors. Now, as you can imagine, gathering more data would not address response error issues. The last kind of non-sampling error is a non-response error. A non-response error, yet another non-sampling error, cannot be estimated easily. Non-response errors occur because respondents don't answer a question. You probably wonder, why would a respondent not answer a question? Well, if you have been, all you've got to do is think back to all the text messages you may have received to click on a link to complete a survey that you ignored, or emails you got to complete a survey that you ignored, to understand the reasons for non-response error. So non-response error occurs because a respondent does not answer a survey that they were sent. Okay, so again, why would somebody not respond to a survey? For a whole host of reasons, right? There could be the respondent may feel may not have the time, may not feel like it's worth their effort. They may feel like the subject is not relevant to them, and so on. Now, this can be a huge issue in practice, because you might take all the effort in the world to pick a sample as carefully as possible using simple random sampling or stratified random sampling. So you might check all the boxes in getting to a perfect sample. And this perfect sample is, let's say, 1,000 people. Now, of these 1,000 people who are sent the survey, only 20 respond, giving you a 2% response rate. That means 980 did not respond. To the extent that the 980 that did not respond are different from the 20 that did respond, you have a non-response error. In other words, the responses obtained from the responders are different from what the non-responders would have said. The 20 people that responded are systematically different from the non-responders. So the best way to address non-response error is to boost response rates. So let's see how we can improve response rates, right? Because we know that poor response rates will lead to biased or non-representative samples. There are a number of ways of improving response rates. And just to kind of preface the issue out here, in practice, whenever I've conducted surveys, I typically get response rates of about 1% to 2%. But I've seen much worse, and I've heard much worse than that. Which means typically you can expect, if you send a survey out to 100 people, 1 will respond on average. So we want to think about how you boost response rates. How do you get more of the 100 or so people to complete the survey. There are many ways of going about this. One of the simplest ways is to sell people on the benefits of the survey to them, emphasize relevance to them. What's in it for them by completing the survey? Or how will they benefit society or somebody else by completing the survey? Tell them about what benefit the survey might serve. A lot of folks will be reticent to answer a survey because they feel that their personal information will be out there. Promising them confidentiality by assuring them that the responses are anonymous and will not be tied back to them will kind of allay some of their fears. Some people will complete a survey if they know that they'll be able to see a report of what was found. So sharing aggregated results, again, might motivate some people to respond to the survey. Now, in my experience, I've found that reminders work amazingly well at boosting response rates. Now, I'm not saying that if you send a reminder to respondents that you'll go from 1% to 100% response rate. Now, that'll never happen. What will happen is if you send a reminder to those who didn't respond when the survey was sent out initially, then a few more will respond. Then you go through the process here and send those who didn't respond by the first reminder, another reminder. And usually I found 3 reminders work really well in boosting response rate, all from, let's say, 1% to about 3% or so. Right? So you basically had a 3-fold increase from sending out reminders. And that's a good reason why you want to send out reminders. Now, the thing about reminders, the one thing that ticks me off is when I get an email saying, if you responded to the survey, thank you. But if you didn't, please click the link and complete the survey. I feel a bit cheated. I feel like I did the right thing. I took the time and effort to complete the survey. And now here is the research company sending me another reminder. Shouldn't they know I completed the survey? So most survey software have the ability to only send reminders to non-responders. You want to make sure you program that into your survey software, whether it's Qualtrics or Zoomerang or SurveyMonkey. In Qualtrics, this works by setting up a panel and make sure that you upload the set of email addresses to the Qualtrics platform, and then it tracks who has responded, who hasn't responded, only sending reminders to those who have not responded then. Incentives, of course, work great. In most cases, folks, if you give people a monetary incentive, it works wonders in getting them to complete a survey. Again, I found here, how you frame the incentive makes a big difference. You could promise people $1 for completing a survey, or you could promise them a 1 in 100 chance of a $100 Visa card. I found promising the 1 in 100 chance of a huge reward leads to more high response rates than promising them a sure $1. Maybe because people think about the $1 and think it's so little that it's not worth it. But the promise of a large reward, even though probabilistic, motivates them to respond. So incentives help. And another way to kind of guarantee responses is to pay people, or to give a survey to paid survey takers. There are these survey panels. People have enlisted themselves as being survey takers. You send them a survey, they guarantee a flat amount of money, they complete the survey, they get their money. Another example is MTurk, or Amazon Mechanical Turk, that has gone from being a place where people can go on to complete small tasks to a survey platform, because a lot of jobs on there are survey jobs. So you could go on to MTurk and specify the sample of people, the profile of people you want to send the survey to. And if it's not too narrow, you can find people who complete the survey for a nominal amount of money, like as little as $1 to $2. Okay. Of course, you've got to keep in mind here that using MTurk means you've got a sampling frame that's this bias, and that might give you a non-coverage error. People on MTurk may not be like typical people, And so you've got some sort of sampling, non-coverage error or non-sampling error from that. Okay. There are also now a couple of innovative survey methods out there to get people to complete surveys. And one category is surveys that don't look like surveys. So think of those IQ tests you've seen on social media that say, what is your IQ? And everybody wants to know how smart they are. Or there's a question like, intriguing question like, what is your mental age? And people want to kind of know that. So they jump in and they answer a bunch of psychological questions. And some of them might be legitimate, but I suspect most of them are not legitimate. They're masking themselves as being one of these tools helping you to know your true mental age, but they're really gathering data from you. And I know that some of them are not even true because I've taken the IQ test a couple of times, and it turns out that every time the IQ number I get is one that really makes me happy. And it turns out people I know are not as smart also end up smiling when they see the IQ score. And so, of course, you can also have people answer questions on social media, like on Twitter or on social media fan pages. I found this interesting, but so of course the constraint is you're on social media, you're limited to answering very small, specific, 2-question type surveys. Okay, now if you have non-response, then there are ways of adjusting for non-response. And here are some ways you could adjust for non-responses. If you find you've got folks who didn't respond, you can contact the non-respondents or a subsample of non-respondents by a separate medium. So if you send a web-based survey that didn't yield responses from some people, then you contact those people using phone or person interviews. The idea here is to gauge, in a sense, are the responders and non-responders the same or not? If they are in fact identical on variables of interest, then one doesn't have to worry about any non-response bias, or for that matter, non-response error, because on the variables of interest, the two groups are not different. The other alternative is to consider other ways, like, for example, using data from a previous survey or some sort of substitution. There are also other methods like we're using subjective estimates, trend analysis, and lastly, you might use some sort of weighting or imputation method to address non-response issues. The bottom line here is non-response is a serious issue. You want to get at that by either reaching out to the non-responders another way or adjusting it statistically or mathematically. To wrap up then, we've discussed here an array of data collection methods. Of those web-based surveys are clearly the forerunner or the front runner. The error in data gathering can be broken down to sampling errors and non-sampling errors. Sampling errors we can estimate, while non-sampling errors should be minimized because those cannot be measured or estimated. One cannot know the extent of non-sampling error there is. One kind of non-sampling error is an error caused by non-response, and this can be addressed by boosting response rates, getting more people to answer the survey. Thank you.